I'm going to present the OSM architecture. I could go through the slides, but I think that it's worth to make some kind of exercise with a whiteboard, okay, to understand more or less the architecture, and then we will see the slides where we will have everything there in place, right? So first of all, whenever you have a system, you could think that there is some kind of northbound interface, okay? What it's called NBI, okay, northbound interface, that it's the one that will consume the other systems that are using it, right? So that's what OSM northbound interface does, okay? Typically, it's offering, well, in this case, in case of OSM, it's offering a northbound API that is based on REST. Okay, as you know, probably REST is or REST APIs are mainly based on HTTP methods, okay? And so it's mainly get, put, delete, post, okay, depending on whether you want to read, create, update, or delete something, okay? That's the REST API. It's based on Sol 5. There are some divergences, as I mentioned before, okay? We are right now in the process of trying to converge, okay? That's why we are doing some conformance tests, and although it's in principle based on the version 1 of the Sol 5 API, there are still some differences, and we are still working on them, okay? This REST API is consumed by different, could be consumed by different clients or different systems. For instance, with OSM, we are providing a CLI client, okay, that's the OSM client, that it's provided as part of the installation, but it could also be part of an standalone installation, okay? So besides that, typically we have the graphical user interface, okay, the GUI, and we have other systems. So those, the CLI and GUI are mainly to use OSM directly, okay, but it's also possible from other systems like OSS, BSS, or any other system to be able to interact with OSM through the NBI, okay? And well, typically that interaction is based on the REST API, is based also on some, let's say, not everybody can do everything, right? So that's why we have users, projects, and roles. Users belong to projects, and each user could have a different role in the project, okay? It could have, depending on the role, it will have different permissions to run or to do different actions, okay? That kind of management of those permissions is done through an authentication module, okay? They will call auth, okay, auth. And this auth is based on Keystone, okay? If you know Keystone, the OpenStack identity and authentication service, okay? We are using the same, okay? We are using Keystone for that. And well, Keystone relies also on a database, MySQL database, that it's part of this auth, okay? So it's purely this auth is Keystone plus a MySQL database, okay? And the interaction between NBI and auth happens for each interaction of the REST API in principle. So whenever a user requests to do something, the NBI gets that, okay? Gets, let's say, whether the user has permission or not, and this is done through this auth, okay? It's also possible to not rely on Keystone, I mean, to rely directly on permissions and store in the database, okay? But typically for production and for the required, let's say, what you would require on production, you will use Keystone, okay? Well, so that's mainly about operations arriving to the system and permissions to do things, okay? This could be the main idea. So sometimes some of the operations would require to just read things from the system, right? So for instance, what are the VIMs that I have registered? What are the case clusters that I have registered? What are the network functions that I have onboarded? The network service packages that I have onboarded, or the instances of network services, right? There are things related to read operations. And also there will be some actions that are mostly required to register things in the system, but without doing anything, right? When this is the case, we will typically store everything in what's called a database, okay, that it's the Mongo database, okay? So we have a Mongo database. Mongo is a NoSQL database, okay? That's the one that we have for storing, let's say, all the information that is an instructor, and it's mainly the information about the descriptors, the VIM registration, the case cluster information, everything is stored in the MongoDB, right? So it's our main common database, okay? The interaction between MVI and MongoDB happens when for every read operation and for all those create and delete operation that doesn't require anything else from the system, right? Okay, so that's where it will happen, okay? Then besides MVI and Mongo and the auth, okay, and CLI and GUI, okay, we have not yet done anything in the system, right? We are mainly registering things. Well, that's what we are doing, right? Sorry, I forgot to mention something. So mostly whenever we need to store something that it's pure JSON or JSON based or something that could be stored as a collection in Mongo database, okay, it will be stored there. But sometimes there will be artifacts that will be required to be stored, right? For that reason, we have an object storage. I will call it object storage here, that it's the component in charge of storing the artifacts, right? For instance, if the package include a UU charm, or I don't know, a logo or a cloud init file, these kind of things, okay, will be stored also in the object storage, okay? That's also here, there's an interaction between them. And then we go to the, let's say, the main components of the system. Let's go one by one, okay? We have LCM, we have VCA, and we have the arrow. There are others, okay, but I will start with this, okay? So as I mentioned before, whenever there is something that it's, let's say, just it's not related to any instantiation at all or any operation, okay, but it's just purely things that are pre-provisioned or onboarded, okay, we are not dealing with LCM, VCA, and arrow. But whenever there is an instantiation or an operation happening, then those modules start being used, okay? So the first case that I will comment is mainly the instantiation, right? And whenever we have an instantiation, the MVI registers the request for instantiate something, okay? And it registers in Mongo, so a new instance is created there, new VNF instances are created, and then it passes the control to LCM. The LCM is the one, LCM is an acronym for Lifecycle Management, and it's in charge of doing, let's say, all the tasks related with the instantiation. So LCM is in charge of the life cycle of that instantiation. It will coordinate the different things to be done, and mainly there are typically two things that are expected to be done when you have an instantiation, right? First one is mostly related to the deployment of the network function, right? If the deployment is on a VIM, okay, I mean, it's about interacting with VIMs to deploy virtual machines and create networks in a VIM, right? Or even in the case when an SDN controller is in charge of doing the connectivity between the different VMs, okay, in a VIM, the arrow is the one responsible for that. So the arrow is the one that will take care of that, will do that interaction, okay, with the VIMs and the SDN controllers to deploy the virtual machines, connect them, okay, that's what's done by the arrow, okay. And once they are running as VMs, right, we have blobs that are the VMs, let's say, running those VIMs, it could happen that there could be some primitives for day one configuration. Let's, I don't know, running some stuff in the virtual machines, right? This is done by the VNF configuration abstraction. Okay, it's the VCA module. Okay, VCA is the acronym that we use in OSM, but in the case of OSM, we are talking about the UU controller and the UU chance. That's the framework for VNF configuration, right? So those are the ones that are talk to the VMs that are running in those VMs, okay, that are deployed over there, okay. That would be the generic case for the VNFs. How all these MBI, LCM, Arrow, and VCA talk each other, right? So there is a Kafka bus that, well, Kafka could be used for different purposes, but in our case, we are using for a message bus as a way to exchange message between the modules, okay? So whenever there is an instantiation request, MBI will publish to Kafka, okay? And LCM will get it, okay? And we'll get that instantiation and will manage the life cycle of that, okay? Then LCM interacts with Arrow and VCA. How this LCM interacts with them? Well, in principle, one could think Kafka, yes, and that's the idea. Okay, we are working on that. Okay, but for the moment, we are still relying on some interfaces that we had from the past. So right now, we are using here an interaction between LCM and Arrow based on a REST API. Okay, so the Arrow is offering a REST API, and for interaction between LCM and VCA, we follow, let's say, interaction through the Juju library, okay? So that we have a client, a Juju client here storing the LCM, okay, that interacts with the VCA that it's a Juju controller, okay? So we follow the Juju lib. I don't know if the Juju lib, I don't remember if it's based on gRPC or I don't remember right now. I don't know if Mark is in the call, maybe he knows, or Maciek maybe knows. About that, I don't remember exactly if it's based on gRPC or REST or any other protocol. Okay. Well, I think that so far so good. As I mentioned before, the idea is that all these in the future could be replaced by a message bus system so that we don't need to interact directly between the modules. So every interaction will happen through Kafka. This has very good benefits, okay? One of them is that you could have a single place where all the messages will go through, and that helps a lot for debugging and logging purposes, okay? Okay, there is, let me comment. Obviously, the normal interface needs to understand the information model. The reason is that it has to understand the descriptors, okay, and understand, validate that the descriptors are correct, okay, whenever there is a request to onboard a VNF package or a network service package, right? That's the main reason why the MBI needs to understand the information model. Obviously, the LCM also needs to understand the information model because in the end, it will have to read the descriptors of the network services, and together with the different instantiation parameters, it will define the tasks to be done. And well, it will have to understand LCM, the information model, and understand the descriptor to know what things have to happen, right? And the Arrow also will have to understand the information model, okay, in order to, because, well, part of the things related to the instantiation are the deployment of virtual machines, and the easiest way to deploy things is to follow the same information model. So pass just an excerpt or an extract, okay, of the descriptor to the Arrow, okay. Well, I think that this is more or less gives you an idea. There are different things also to be taken into account. Is that MON, there is a component that it's MON monitoring, okay. This monitoring is providing the monitoring capabilities of OSM. It's mainly having also different collectors to talk to the VIMs to get metrics from the VIM, okay, or from the SDN controllers, okay. Whenever there is an instantiation, MON will get from Kafka let's say the message that there is a new instance that is expected to be created, and MON will take care of the, let's say, newly created VMs, okay, and things created to monitor their CPU, memory, etc. So, and MON gets aware of all this through Kafka, okay, also. Because, well, everything that it's instantiated, whenever there is an instantiation, MBI publishes in Kafka, LCM consumes it, and whenever LCM finishes the instantiation, it will publish the result through Kafka, and MON will be aware of that and will be able to talk later on to the VIM to request for the CPU, memory, etc. of the different VMs, okay? That's more or less the idea. There is also a policy module that is in charge of applying or to take policy decisions, mainly based on scaling. Okay, it also consumes from the MBI. So whenever there is a scale request, the policy module will be aware of that. Okay. Okay, and that's also happening through Kafka. Sorry about the noise. Sorry for the noise. Okay, I have the kids at home, and well, it's complicated. What else? I think that we have covered more or less everything right now in the figure. Well, there's also something else that I will also comment is that all the metrics related to the monitoring module are stored in also in a database that it's a time series database based on Prometheus. Okay, time series database based on Prometheus where all the metrics are stored. Okay, and that Prometheus, well, all those metrics from Mon are stored there in time series database Prometheus, and we have also a Grafana module that allows you to check that. Well, I think that that's more or less the main picture. Okay, I think that you get the idea. There are details, for instance, how LCM and VCA interacts is usually, but it's specifically through a library that it's installed in the LCM, and it's a very important library. It's N2VC. Okay, that it's here, N2VC. That's the library that interacts with the VCA. Okay, that library is not only in charge of talking to the VCA, but it's also handling all the interaction with the case clusters. So for the case clusters, instead of relying on the arrow, we thought that it could be, we didn't need to use or overload arrow with that load. So whenever there is an interaction with the case cluster for the deployment of KNFs, it's done directly through the N2VC. Okay, so N2VC will interact directly with the GU cluster. It could do it through VCA, or it could do it directly through the case cluster there. It could interact directly, depending on the case, okay? And well, I think that more or less this is the idea of the whiteboard session, that you could get a picture, okay? Now let me go to the presentation back and check that everything more or less fits with what I mentioned, okay? Well, as I mentioned before, I think that this is more or less, okay, what we commented, right? So we have the MBI. The MBI is, well, it's a unified northbound interface. It's decoupled from the lifecycle management. It's good to have it decoupled so that some operations that are not requiring to do any instantiation, any interaction or deployment of anything or any configuration could happen directly between the MBI and the database, right? That's the reason why it's decoupled from the lifecycle management. All the end-to-end orchestration happens through the lifecycle manager. There is a message bus, a Kafka bus for communications between the modules. Still, there are some communications between LCM and VCA and LCM and RO. We have a common database, auth, and object storage. We have a common database for, well, almost everything is in the common database, the descriptor information, the instantiation information, the case cluster information, VIM information, everything is there, right? The object storage, whenever there is an artifact in a package, it's stored here. The auth for, let's say, an interaction between MBI and auth happens for getting the permissions, okay, required to do an operation. So if an operation is not allowed, it will be rejected promptly in the MBI. We have components, integrated components for policy, fault, performance management, and placement. Those are the ones here that will hear from Kafka bus different messages and publish other messages there. So depending on the operations, they will interact, okay, but they will do it always through the Kafka bus, okay? And well, they have been added, okay? I think that it was a good idea to have the Kafka bus because it allowed us to add new modules as we were requiring. So from release 5, I think, or 6, we were adding modules consuming messages directly from the Kafka bus and then publishing there any output, okay? We have complete control of the system through the CLI and the GUI, okay? And finally, we have all the execution environments for VNF configuration happens through VCA, I think, well, through the channels, okay, that are deployed by VCA, okay? I think that those are mainly the ideas, okay, that you should be aware of. I would like also to make a comment about the something that is very interesting. I think it's the plugin model that we follow in OSM. So in OSM, we are, this figure might not be completed, but I think that you could get the main idea, right? Is that the modules that are interacting with the different VIMs, for instance, the arrow is in charge of deploying VMs and networks in a VIM, right? So it will interact with OpenStack, with VMware, VCD, AWS, Google Cloud, okay, Azure, okay. So we have in the arrow a plugin model. So whenever we want to interact with a new cloud provider, we develop a set of calls according to a defined connector, okay, and that allows us to interact with that cloud, okay. That's why what we call a plugin model, okay. We just need to create a new connector or a new plugin, okay, to interact with that cloud, and that would be all. The same for the SDN controllers. We have plugins for ONOS and Floodlight and ODL, and we have also plugins for inter-data center communication. So mainly sorry, is there any question? Okay. We have, for instance, right now one for IETF L2 VPN and another for an ODL-based WIP, okay? There are others, well, I don't have all the details, but you have all the details in the documentation, I guess. Then for the monitoring, we have a similar situation, right? For the monitoring, we have to interact with the different VIMs, okay? To get the metrics. The plugin model for the arrow, for the monitoring and for MON, and it's being evolved. I will comment a little bit about that later. Okay, but what we have right now is a set of plugins or collectors that are in charge of getting metrics and storing them, okay, in the database, okay? So they are getting CPU metrics, etc. We have also a plugin for collecting BNF metrics directly from the BNF. Well, this is complicated to understand. I think I will comment later. Then for the rest of things, for the message bus, the object storage, the common database, the role-based access control, or the authentication, let's say, all the permissions, etc., we have also a plugin model for that. The reason is that, well, we don't want to get, let's say, to close our options, right? So we don't want to let's say, get stuck on a specific option. So that's why we are following a message plugin also for them. So that means that, for instance, for the message bus, we are using today Kafka, but in the future we could use something different. So all we need to do is to create a plugin, okay, for all the messages, let's say, for dealing with the messages, right? In fact, we have a file system plugin, that's how we call it, okay, where we publish all our messages in a file system and then read them from there, okay? And this is useful for debugging, for developing also. It could be useful, okay? For the object storage, pretty similar. I think that today we are relying on Mongo, I think, for some of this. I'm not sure about that. I don't know why it's not here, but well, anyway, I think that we are relying on the I don't know if it's something like IngridFS for Mongo or something like that. I'm not sure, okay, for the object storage, but we could have all in the future. For instance, it doesn't matter, but you could have a Ceph plugin, okay. For the common database, we store it in Mongo, but we could store everything in file system, okay. There was also a plugin for that, also useful for development. And for the MBI, we could manage all the permissions through Keystone, or we could manage directly from Mongo, okay. That's the options that we have, okay. Well, and now, I have a set of slides describing different operations so we could understand the modules involved on them. Before that, let me go very quickly to the installation that we did yesterday, because it could be useful for you to understand what's that everything that we mentioned, it's here in our instance, right? So let me check. Well, first of all, I mentioned that everything is running in principle on Kubernetes, okay? So we have all the things that I mentioned before, right? We had a deployment for the arrow, for POL, policy module, NGUI, the graphical interface, normal interface, the monitoring, LCM, Keystone, Grafana, okay, Keystone for authentication, Grafana. So we have all of them here. For the stateful system, we have Kafka, we have the MongoDB, okay, MySQL. MySQL is used by Mon and Paul, okay, and also by by Keystone today, okay, but in the future we need to think about, well, what would be the best way to do it. Obviously, since they are databases, they are stateful sets, and we have also Prometheus, and well, so to keep it at, in case you are not aware of what it is, it's mainly related to Kafka, okay, it's a way to, so everything that requires a state, it's here, okay, it's a stateful set. And also we have there running Juju. If you have heard about OSM in the past, sorry, we have two models running in Juju. Juju, I think that you will have some time to understand what Juju is, but mainly what we deploy with OSM is, for instance, all these MongoDB gates here, it's deployed with Juju. Okay, the reason is we are relying on something that is well prepared for the management of the different replicas. Okay, so it's providing, and there is currently a Juju channel, okay, in charge of doing that. Okay, we could check, for instance, in the model OSM, what's there. Yeah, you see that in the model OSM we have the controls, switch. I don't remember how to switch model my controller, right? So let's switch. Okay, now you have here, for instance, the MongoDB running. Okay, it was deployed as part of the installation with MongoDB. Also, in the end, you see it here, right, with kubectl. Okay, but just so that you understand what's going on there. Okay, you have here MongoDB here. Okay, that it's deployed, right? And we have also, let me check what else. It's worth to be mentioned that in the past we had a Juju controller running in Kubernetes, in LXD. So whenever we were doing, it was running as a LXD container here, the Juju controller. Now it's not the case. And if we check here the models, Juju models, you see that there is a controller there, okay? And that controller is running specifically in our Kubernetes cluster, okay? That's why you see here this model operator stuff, I think, here running, okay? Because it's been deployed by you, okay? Well, I think that's enough. You don't need to understand all the details, but just get the picture, okay? So let's go to some of the operations that we had, that we could do, okay, with OSM and understand the different modules involved. So, for instance, identity and assignment operations, so creation, modification, deletion of users, projects, roles, etc. Right? Well, so definitely there is nothing here in those operations related to instantiation or BNF operation or configuration, right? So that's why you don't see here LCM, R1, BCA. So everything happens between the MBI, the common database, obviously, Keystone for the, let's say, the doing the right changes, okay, related to permissions or the new users, modifications, etc. that would be required, right? And well, and the database that is used by Keystone, that it's the MySQL, okay? There are cases where there could be backend integration with LDAP, okay, for the identity-only purposes, okay, and well, that's also captured here for your understanding, okay? But we don't have here an LDAP module per se, okay? Well, what happens when we upload packages? Okay, when we upload packages, here's an example of the CLI call, okay, OSM NF package create and the package, okay. we will do an API call again through the MVI, and the different artifacts will be stored in the object storage, and the descriptors will be stored in the common database, okay? And the structures related to the VNF package or the VNF resource, let's say, are going to be stored in the common database, okay? I think it's pretty simple to understand. Now we are going to a more complicated case. Okay, register in a VIM, okay, a new VIM or an SDN controller. For instance, we register a VIM, we provide register a VIM with a name, user, password, the auth URL, tenant, etc. Okay. Well, we will do the API call again through the MVI. Well, there is all the stuff related to permissions that I'm not showing this picture, but you could understand that all the permissions are checked, the interaction there happens, okay, with the auth module, or this happens there. Then once we have checked that we have the right permissions, we will store the store the VIM data or the information in the common database. Okay, so we will all this information will be stored in the VIM in the data stored in the database, in the common database in Mongo, and then we will publish a message through Kafka that tells about, please register this VIM. Okay, this is required because Arrow in the end will have to talk to the VIM, okay? And it's useful to do some initialization in the Arrow, okay, to create the necessary, let's say, runtime environments to interact with the VIM. Okay, so that's what happens through this line here when a VIM is registered. In addition to that, whenever a VIM is registered, that registration is also, and that registration happens through Kafka. So MVI publishes a message, please, I want to register this VIM. LCM gets it, informs the RO that then interacts with the VIM and do the initialization, right? So this is mainly a pure initialization of the runtime environment for the RO, okay? But MON, the monitoring module, also gets aware of that, okay? And it will initialize also a runtime environment, a collector, to get metrics from the VIM, okay? And those metrics involve two things, right? First, the VIM connection status, is the VIM API reachable or not? And the other is the different metrics that could happen later on during instantiation, okay? But all the runtime is initialized here. Well, and that's what more or less happens when registering a VIM on an SDN. With an SDN controller happens the same, right? So also the runtime environment is created in the arrow, and the runtime environment or the collector is initialized in MON, okay? Adding a cage cluster. A cage cluster is slightly different. So in previous releases of OSM, well, let me go very quickly. Obviously, the MVI, the API call, okay, through the MVI. Then we store all the information about that cage cluster in the common database. And we publish a message in Kafka to register that cage cluster. And that message is understood by LCM and MON. LCM, in principle, should call to the should do any initialization of the cluster if it's required, right? And that happens. I have not captured that, but well, that initialization happens through VCA. Sorry about that, I missed that picture, okay? And that initialization will happen also here, okay? And for the monitoring, also the same, okay? For the MON will be aware of that registration of the cage cluster and will be able to know if the API is reachable or not. Yeah, so mainly it's the same, right? There is first of all an API call, obviously through the CLI, UI, or any other system. The MVI reaches an instant. It reaches the request to instantiate something to create a new instance of a network service. Then all the network service record, or all the, let's say, for every network service instance, there is a record. For every VNF instance that will be created, there is a record too. Those are stored in the common database. And then once those, let's say, empty boxes or empty records are created, we publish a message in Kafka to do the instantiation. That call is received by LCM. That first of all, we'll call the RO mainly to deploy the different VMs, and that RO will do the right API calls to the VIMs to the different connectors. Okay, and also Mon will receive the instantiation, and whenever the instantiation completes, Mon will receive a message in Kafka, and that message will be used to start the monitoring of the already created VMs. Okay, so that's what also happens. I'm skipping right now the part related to the BNF configuration because I will comment in the next slide. Okay, but it also happens during the instantiation. There is a question regarding the registering of a case cluster to OSM. Could you explain a bit further the field case nets? Well, it was not my purpose to go into the details of the case cluster, Dimitris. I mean, it's not part of the. I mean, you are asking specifically about the commands and way to create it, right? I could try to give you pointers there, okay, so that we could probably, let me go to the docs here. This is the, well, typically when we are registering a case cluster, we need to associate it to a VIM, okay? So the question about the networks or the meaning of the networks is because when we create a case cluster, we are providing some information about the networks, okay? Like in here, case cluster add, we are providing the credentials of the case cluster, typically the kubeconfig, okay? The version of the cluster, the VIM that it is associated to, and I feel here that it's case nets, okay? In principle, the idea is that a case cluster is not isolated. So a case cluster is typically a set of nodes running on a, and well set in a network, okay, where all this Kubernetes networking happens, okay? And that network, if the Kubernetes cluster has been deployed in a VIM, is typically in a virtual network in that VIM. So for instance, you have different nodes of the cluster here in a VIM. There is typically a virtual network in that VIM, and that's the one used by all the network, or sorry, all the nodes to communicate, right? So that would be the mapping that you will have to specify here, that the Kubernetes cluster has one network, and that network is that VIMnet. This helps later on whenever we are going to deploy an hybrid network function or a network service consisting of a BNF and a CNF to be able to connect them properly, okay? So it will let us know, for instance, that without the need to specify it, that the BNF needs to be connected to the same network where the CNF is expected, okay, to be running, that it's here, okay, all the APIs will come from, for this CNF will come from the network, okay, and it will allow that us to be able to interact between the BNF that could be running in the VIM and the CNF. That's the reason of that addition, okay? If you are working with isolated classes, you could skip that and just provide here this information with casenet 1 null, okay? Here it doesn't matter the name that you put here, okay? It's just a field, empty field that will be used as the name that you are giving to your network, and it's connected to nothing, okay, in the VIM, okay? It's complicated. I don't want to go into the details now because it probably requires a dedicated session, okay? Was that answering your question, Dimitris? I hope so. Yeah. How BNF get updated in Mongo during a scaling procedure? Well, it's a good question. Too complex probably for this session, right? Mainly in the end, for the, let me go back to this. Whenever there is a scale request, it will be receiving the MBI, and poll module will take care of that, okay? Poll module, poll module will take decisions for auto scaling and will publish a scale action here. In the case of a direct scale through a normal interface, it will be published from the MBI to LCM. LCM will, all the modules here, MBI, LCM, RO, have access to the common database. So whenever there is anything new, the different records are updated because, well, LCM, RO, all they have access to the common database. They are able to, they have a specific space or specific places in the BNF record that are managed by themselves. So let's think of the BNF record as a collection of fields. some of them are readable by all the modules and others are writable only by one of the modules, okay? That's how, in general, we work with the records, okay? That's your question. It's too complex, Vyacheslav, to explain, but what I would suggest that you do a scale operation, okay, following the guidelines here. I don't know if, let me check here, the scale, OSM usage, the VDU to be scaled, monitoring and auto-scaling, VIM metrics. Probably it's good that you scale directly. You take one of the packages that we have in the OSM packages repo that could be useful for you to try, and then you run a scale operation there, and well, you check later on with the BNF show in the command CLI tool in the OSM client, the record, okay, and you read directly from there, okay. Does creation of a network service instance require a VIM account? Well, we need to specify where the network services, the VNFs will be deployed, right? In this case, we are specifying a VIM account common to all the VNFs in the network service, but we could be more specific. And as part of here of the command line or the GUI, we could pass some instantiation parameters that could include, I want this VNF to run in this VIM account and this other VNF in a different VIM account, okay? Well, so finally, the last workflow that I was planning to present was the NS primitives. Well, whenever we are launching a day 2 operation, or even when there is a day 1 primitive related to a network service instantiation, there will be some configuration to be done in a VNF. So in the case of the day 1, the request will happen directly as part of the lifecycle management of the instance. Okay, so after the deployment of the VMs through the arrow, LCM will take care of the next steps. Okay. In the case of a day 2 operation, obviously there is a call through the northbound interface. That call, well, the action will be stored in common database because all the operations that happen in a network service are stored in the common database. And then the message is published to Kafka and it's received by LCM that to run that primitive. And now what happens in LCM? Okay, so typically, but for most of the primitives, what we do is that we call BCA, okay, and BCAs, we call the UU controller through the UU library, and that UU controller talks to the UU charm to do the interaction with the network function. That could be, in the case of the typical cases that we are following, it says SSH interaction when we are running some commands there, but it could be based on any other protocol. I think that you will have more time in the next sessions, in the next days, to talk about that interaction and the day 1 and day 2 configuration. Okay, there is also another path that has been enabled, and this has been enabled mainly for the collection of metrics, that it's the deployment of an execution environment on Helm in the same cluster where OSM is running, okay, and allows you, for instance, to run primitives related to the configuration of that execution environment to get metrics. And this is used, for instance, for the way we are dealing with the SNMP metrics in OSM, okay. Additional parameters that we can pass with the NS instance are only limited to the set mentioned in docs. Yes, I think that those are the ones mentioned in here. Yes, I would say that for the case of the CNFs, for our KNF, Kubernetes-based VNFs, you could pass the parameters. Also, you could have parameters like this. I think that they are not covered in the NS instantiation parameters. You could pass parameters by specifying for each VNF, you could pass for each KDU, or KDU is the object inside the VNF that is prepared for Kubernetes. It could be a Helm chart or a UU bundle. You could pass for each of them the additional parameters that you want. For instance, if the KDU is based on Helm, okay, you could pass here as part of this dictionary here the whole set of values that you could pass on a Helm chart, okay? And that's something that it's not part of the instantiation parameters section here, okay? That you mentioned in Dixa. So in general, you are right, those are the parameters here, but in the case of Helm charts and instantiation, we could we could move to the, yeah, you could add the other ones. Okay. Well, now I think those are the network service primitives. I had included some slides related to the monitoring framework that Subankar made a good presentation recently about the monitoring framework. I think that you have them here. I think there is not enough time to cover them, but in general, in the monitoring framework in MON, there are collectors that are in charge of collecting metrics, okay, and what they can do is mainly collect VIM metrics about what's the is the VIM reachable, is the API reachable, so it's the status, okay. You could also get the infrastructure metrics, let's say CPU, memory, and what's called video infrastructure metrics, CPU, memory, and disk, and network metrics from the VMs. We could have metrics from VCA, and there is a way to let the UU charm communicate metrics to OSM back, and that's what's here, considered as BNF metrics indicators. We also have the BNF specific metrics, like for instance, a BNF that could have some metrics based on SNMP, and we could have Prometheus exporters, and those Prometheus exporters, well, would be also providing us those metrics, okay? We have the SDN controller status metrics and case monitoring that was introduced in the last release, release 11. I think that, well, I think that we don't have enough time to go into all the details. We have here some information. If you have any question, I think that it's worth that you could ask in the Slack channel here. Let me check here in Slack. You have a service assurance channel here where you could talk about well, things related to service assurance and monitoring, okay, in general. Okay, and that would be more or less the content of the talk. There is also, well, I included a slide related to troubleshooting. A general approach for troubleshooting is to first look in the output of the commands, OSM NSO, VIM show, okay, that will give you some details about the status of the network service, status of the VIM, okay. But in general, whenever you are doing something, well, an instantiation typically, or something that requires more troubleshooting, it's good that you check the logs. And here you could see in the troubleshooting section some of the common things, right? So typically the logs, you could get the logs of anything, right, running a kubectl command, okay, and that would be all. For instance, let me show you for, I don't know, for the arrow logs here. Okay, it's an example. Okay, so you could have here the logs and follow the logs here, and well, whenever you are doing an instantiation, you could check them in that way. Okay, so that could be all that I had prepared for my talk today. Well, I hope that it hasn't been too dense. I just wanted to give you an overview. I think that the whiteboard helps to understand the decisions and the different, well, processes that are involved, and I hope that you have got a picture of the internals. Okay.